What's going up, everybody? So I had a couple of questions on worksheet 7 that some of you guys emailed me. So I am going to go over just a few of these problems to help you guys out. So the first one that I'm going to work on is this isosceles trapezoid here. So right now, if we look here in this isosceles trapezoid number one, it tells us again that it's an isosceles trapezoid. So if you remember the descriptor I used in class, an isosceles trapezoid pretty much is an isosceles triangle that was just cut, right? The tip was cut off. So what do we know about isosceles triangles? That the base angles are congruent. So once we find DAC there, which is this one right here, we find this part, we'll be able to add that to 35 to then get ABC, which is this one over here. But let's go ahead and we'll get to the rest as we get to them, right? So let's do this. So with an isosceles trapezoid, again, we do know that this side is congruent, or this angle is congruent to this angle. This side is parallel to this side. And we know one other thing, and that's that this angle is congruent to this angle here. And I'm going to do this. Boom, 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 just so that we don't have too much on there. Okay. All right. Now, knowing that, let's go ahead and take a look. Well, we should already know automatically what angle this is. Now, the reason we should automatically know this is because I've got two parallel lines here. I've got a transversal here. So therefore, I know that this angle here is congruent to this angle by alternate interior angle theorem. We learned that a lot. Well, what was it? Semester one? Alternate interior angles. And alternate interior angles are congruent. So I found right away ACD. ACD is 35 degrees. 35 degrees. And again, that is only true because these here are parallel and this is on transversal here. All right, so we found ACD. Now that I found ACD, I can find ACE because these angles here are congruent, right? So all I have to do is take 130. So I have, remember, angle D is going to be equal to angle C, the whole thing. Or in this case, it's going to be ACD plus a angle ACB. We know ACD is 35. We know that angle D is 130. So therefore, ACB, we can find by just subtracting 35 on both sides, giving us 95 as angle ACB. So right away, we found it. And I put 90 when it should be 95. 95. Cool. But how am I going to find the rest? Well, I found that this is 95. I found that ACD is 35. Now I've got a triangle here. And all that's left to find this triangle is I need to find this angle right here. And I can do that because, like I stated, this is a triangle. And all triangles, interior angles have to add up to 180. So if I do 130 plus 35 plus DAC, right, this angle right here, these should always add up to 180. So I get 165 plus angle DAC is equal to 180. So I subtract 165 from both, and I get angle DAC is equal to 15. Perfect. And remember, the first thing I stated right in the beginning, angle A is going to be congruent to angle B. So if I have 15 degrees here, I have 35 degrees right here. Then 15 plus 35 gives us all of A, which will be congruent to B. So B is equal to 15 plus 35, being 50. And we're done, right? So it wasn't too bad. Didn't have to do too much here. And again, this is because it's an isosceles triangle or trapezoid. So won't be too difficult. I didn't get a lot of questions for number two, but I am just going to go ahead and remind you of some properties that will help you. So, um, on and I saw on a kite here. Remember that these two little sides here are going to be congruent, and then also remember that the this entire inside here, the intersection of those diagonals, those are all at a 90-degree angle. So knowing that, I think most of you will be able to finish this up and and finish it up. Oh, and one last thing. Remember that these angles are going to be congruent. Okay. Now, the other problem I wanted to go for on this homework is unit three, or unit question three. The reason being is because this one can be a little bit difficult. Um, why is this difficult? Well, if we take a look here, it kind of looks like we're going to have to do not a system, a quadratic equation here. Now, a quadratic is fine, right? But I just wanted to remind you guys how to do those so that you can do them on the test. So let's take a look here. Again, another isosceles trapezoid. So I'm going to go ahead and mark my base angles, and I'm going to go ahead and mark these angles here as well to tell me that these are congruent. Wonderful. Okay, I know that angle G is x squared plus 20 or plus 60. Right, that's what it was. Yeah. I know that angle H is 15x plus 20. And then I know that angle F is 4y plus 1. And that's all we know so far. Okay, so one thing to remember once again is that these two lines are going to be parallel. And this line here is a transversal. So knowing that, I know that these two here on this little area, on these two lines with the transversal here, these are going to be, and when I say these, I mean this, this one and this one, right? Those are going to be same side interior angles. And if you guys remember same side interior angles, well, that's same side supplementary, right? Same side supplementary. So these add up to 180. My first equation that we're going to go ahead and write is going to be x squared plus 60 plus 15x plus 20 is equal to 180. From here, we're going to go ahead and just do x squared plus 15x plus 80 equals 180. And now, a lot of you guys like to go ahead and subtract by 80, but we can't do that. What we want to do is, because this is a quadratic equation, we actually want to set it equal to 0. That way we don't cancel out any of our solutions. So this is going to be x squared plus 15x equals to minus 100 equals to 0. I don't know why that's not working. Maybe a dead spot there on my iPad. But now we have to find multiples of 100 that add up to 15, negative 100 that add up to 15. And here you can use the X method. I just like a table because I can write so many more pairs there, or multiples more neatly. All right, so negative 100. All right. Since this is positive, that means the bigger number is going to be positive. So I'm going to leave negatives here, right? And make those the smaller numbers, and the bigger numbers are all going to be positive. So my first one is negative 1 and 100. That gives me 99. Negative 2 and 50. That gives me negative 48. I'm going to skip 4. That doesn't really seem like it's going to work. What about 5? Oh, yeah, negative 5 and 20. Now, 20 minus 5, right, is going to be 15. Negative 5 plus 20 is 15. So I found my two answers here. Um, right, this is going to be negative 5 plus 20 being 15. So I'm going to go ahead and write my quadratic x minus 5, x plus, and these are equal to 0. Now remember, using my zero property product rule, zero product property rule, I forget how it's how you what the actual name of it is. But that just means that we're going to go ahead and set this x minus 5 to 0, and we're going to set this x plus 20 equal to 0, and then we can go ahead and just solve for x. Great. My two answers here appear to be x equals 5, x equals -20. Now, generally, we like to just say, oh, well, we can't have negatives, so let's go ahead and cross out that -20. But what I like to do is I like just to plug them in and check to see if they work out. Um, right? And sometimes, yeah, sometimes it is. Most of the time, I feel like it is a -20, but we always like to double check it anyway. And the one that I don't really like to check is I don't like to check this quadratic because whether it's a positive or a negative, unless we're subtracting this quadratic, a lot of the times it's just going to stay positive, right? If this is a big positive number and I add another positive number to it, this is just going to be a bigger positive number. Versus here, if this is a big enough negative, no matter how much I add here from the 20, I'm not going to get past the negative. So I'm going to go ahead and check using this equation. You can always check both, but I'm just always trying to give you guys, and again, if this works out, you always want to then check this one. But I always like to give you guys like little shortcuts that I'd like to use to figure out whether it's going to work out or not without having to check both. Okay, so I'm going to go ahead and write this is 15 times -20 plus 20. Well, this is -300, right? Plus 20. Yeah, that's going to stay pretty negative. So my answer cannot be this -20. So my answer up here has to be 5. And now we're going to go ahead and plug in that 5 into the x um, because I know, again, once we're trying to find y. So we're finding this. So if I plug in x into here, 5 squared plus 60. Remember that x equal to 5. I end up getting that angle G is equal to 25 plus 60. So angle G is equal to 85. Awesome. So I found that, but why is that helpful? Well, remember, angle G is congruent to angle F, and we are looking for Y. So now that I know that what F is, 4y plus 1 is equal to 85, I'm able to just go ahead and solve for Y. Um, no, what is that? Why did I write 8? Martinez writing 8 for some reason. 21. Wonderful. Found my answer. Y is 21. Right. So we have to know a little bit about our trapezoids here just to be able to get some of these problems done. All right. Now, one more thing that I'm going to talk about this because I didn't get any other questions on these problems. I don't know, for some reason, trapezoid seems to be giving you guys a lot of issues. Um, But remember, again, the mid-segment formula here, I'm just going to set that up for anybody that needs it. Remember that the mid-segment is always going to be the average of both of my bases. So if my base here is 2x plus 1, and this base here is 5x minus 2, we're going to go ahead and add those together, divide them by 2, and that should give us my mid-segment, right? And my mid-segment here was NO being 3x plus 6. So personally, my first step here would be to multiply by 2, right? Giving us 6x plus 12 is equal to, now you combine these, 7x minus 1. And now you can go ahead and solve for x, no problem. Let's take a look now down here. And then this is all I'm going to do for this problem, for this worksheet. And then I'm going to go ahead and do another video for some of worksheet 8. So give the most descriptive name for the quadrilaterals below. Well, here, right, the only thing that we can really do, and remember, kind of some of our in our notes are trees, right? Especially the one that we learned today. This tree is so helpful because it encompasses both the tree from lesson 4 along with the no pairs and the one pair. And you can start following along through that tree to find these. But again, it's not going to be perfect, especially since we don't have coordinates here to use it well. Um, but here, I do know that all of these sides here are congruent, but because I'm not sure that these are 90 degrees and I can't state that, remember, it could possibly be that they are, but because we can't guarantee that these are 90, the most we can say here is that this is a rhombus. And the reason for that is because remember, all squares are rhombuses, but not all rhombuses are squares, right? And so because of that, we can't go past the rhombus. We can't just assume these are 90 degrees. So I'd go as far as just saying it's a rhombus. Now here, again, I have two parallel lines here, but we don't know the length of these. And because we don't know the length of these, if I were to change this a little bit, just so that we can see um, a different view of what they're showing us, just not to scale, or I guess more to scale, right? Here you can kind of see this kind of looks a little bit like an isosceles trapezoid, and that was not on purpose, but you can see that this makes a trapezoid. And if these two are congruent, okay, then it's an isosceles trapezoid. But since they're not, this here, the only thing we can really say, right, is that these are a trapezoid. They have one pair of parallel sides, and remember, when we have that, we can say it's a trapezoid, and it could be it could be an isosceles trapezoid or just a regular trapezoid. Now now I guess not talking about isosceles trapezoids. If you look at 11, that would be an isosceles trapezoid because again, now if I take this picture and I add and I duplicate it, right? Because it's saying the same thing, right? Right? It's saying that the top and the bottom are parallel, but now I add congruency symbols. Now you can clearly see that's an isosceles trapezoid, right? And so isosceles trapezoid. I don't want to do trap. And again, that's just because we don't know if these are parallel or not. And if they were, then we could say this is a rectangle, but or a parallelogram. Uh, Personally, I would say rectangle. But here again, it has to be an isosceles trapezoid. Now, this is a little bit difficult, right? We don't know anything about the inside. However, we do know that these are bisected and that these are bisected. So, since we know that opposite sides are bisected, you would want, I know a lot of us are going to want to say that this is a square, right? Because the only two shapes who have bisecting angles are going to be squares and rhombus. But again, because we know that has to be different than this, that means that these two cannot be equal to 90 each. So the farthest that we can possibly go is saying that these are rhombus. And then for the last one, number 13, oh, look at that. Diagonals cross at a 90 degree. What do we know does that? Kites, squares, and rhombuses, right? So for sure, this could be one of those. The reason I know for sure this is a kite is because adjacent sides here or consecutive sides are going to be congruent. And so those two are congruent, and then these two are congruent, making this a kite. And that's it. So that's all I'm going to do for worksheet 7. If you guys have any questions, again, please feel free to message me and I will help you as best as I can. I'm now going to go ahead and create another video for worksheet 8. I'll see you guys in class tomorrow. See ya.